Hello Master 311 students, let's begin number theory. Finally, we are beginning number theory. After a week-long discussion on some preliminaries and peripheral topics, and some foundation too, we are finally ready to start number theory. We're going to begin with the divisibility theory, which corresponds to chapter 2 of our textbook. Yeah, here's the textbook. And chapter 1, we went through all these and a whole lot more, actually. And chapter 2, we have to go through all these. And that's a lot. We're going to spend 2 weeks on it. Lesson 2 and lesson 3. At least that's the plan. Let's go back to our lesson notebook. And let's begin section 1. Actually, there's some reviews to do. Starting from an important note. Remember this? Number theory is about integers. From this point on, therefore, we're going to assume all characters stand for integers, unless specified otherwise. Here's an example. If I say m is greater than 1, that means m is either 2, 3, 4, and so on and so forth. So m is greater than 1 means m is greater than or equal to 2. They're the same. No 1.1, no 1.75, anything like that. And here's another example. R is greater than or equal to 0 and strictly less than m means R is 0, 1, 2, 3, and so on, all the way up to m minus 1, not m. Those kind of things. Otherwise, you must be familiar with all those. Actually, you should be familiar with that one too. It's just that it was important enough to mention again. Remember this? No inverse in general, so you cannot divide freely. Sometimes you can, sometimes you can't. That's what the divisibility is all about, which we are about to start. Remember these two properties, zero divisors, no zero divisors, and then cancellation rule. Order properties, z is linearly ordered, but z plus is well ordered. Z minus is also well ordered, but in reversed order, those kind of things. And then inductive properties. Yes, we can use mathematical induction, strong induction, whatever. Finally, some notation issue. Important subset of integers. One such thing is a set of whole numbers, 0, 1, 2, 3, and so on, and a set of positive integers, 1, 2, 3, 4, 5, 6, and so on, or the natural numbers, and the set of natural numbers, it's a bit ambiguous. Some people define natural numbers as this, and most people in the United States do, so do I. But there are some people who define natural numbers like this, so I'll try not to use n. But sometimes I do. Next, this too is a bit ambiguous, but as far as this course is concerned, we're going to assume z sub m is this set. 0, 1, 2, 3, 4, and so on up to m minus 1. Basically, it's an interval of integers from 0 to m minus 1. Greater than or equal to 0, and strictly less than m. Now in abstract algebra, we define z sub m as a quotient set of a certain equivalence relation, congruence modulo m, but that's a bit too deep. That's 4000 level. Here in number theory, let's just stick to 0, 1, 2, 3, and so on, up to m minus 1. Just m integers, starting from 0. Next, prime numbers. Everybody knows that, right? 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. And prime numbers are important topics in number theory. It's really ancient. And maybe we're going to be using this kind of notation too for odd prime, because it turns out 2 is rather exceptional. It's an oddball prime. So many times we consider odd primes only, or primes greater than 2. How about these notations here? mz versus mz plus k. Multiples of m times certain integer. 0m is 0, 1m, 2m, 3m, 4m, 5m, and so on, and also negative. And here, m times certain integer plus k So for example, m is 2, then these are even numbers, multiples of 2, and these are odd numbers. Okay, so much for review, and we are now ready to start section 1, divisibility. Okay, let's begin. Here's the definition of the divisibility. We say an integer d divides an integer a and write like this. Oh yeah, here's a little bit bigger font. D divides a. If a can be written as a product q times d for some integer q for quotient actually, or the fraction a over d happens to be integer. This notation is not very good in general because we want to avoid the division as much as possible, but if you do have divisibility, then of course that's acceptable. So yeah, okay. But not all fraction is valid, so this kind of expression here is best avoided. Yeah, okay, let's go back and de-emphasize those back. This expression is far more desirable. A is q times d. If d divides a, we say d is a divisor or a factor of a, and a is a multiple of d. Remember all those terms? And also the properties of divisibility. Remember all those? You should be familiar with all those properties, yes, but you have to prove those. And that's going to be part of your homework this week. For example, how do you prove n divides n? Your m is to prove n is some integer times n. So what times n? Of course, it's going to be 1 times n, and 1 is an integer. So yes, it works. So reflexivity is no big deal. How about the next one, transitivity? A divides B and B divides C, then A divides C. Okay, how do you prove that? A divides B, what does that mean? That means, oops, sorry about the typo. B is some q times A. Is that right? After all, that's the definition of the divisibility. How about B divides C? C should be some q times B, right? And then with these, you have to prove A divides C. So C is some q times A. That's what you have to do, right? Is that it? Wrong. Badly wrong. But I do see this kind of answers a lot. What's the problem here? I'm using same q's for all those. They have to be different quotient. B is some integer times A, say q1, and C is some integer times B, and that some integer doesn't have to be the same one as before. So we need two different characters, say q1 and q2, or q and some other character. But if you use some other character, then very soon you're going to run out of alphabets. So make full use of those indices. And then here, of course, some integer times A, that's what you want. So how do you get this using these two? Well, C is q2 times B. So let's read it like this, q2 times B, and no question about that, that is true. But then again, what is B? B is q1 times A, so that's q2, which was there before, and q1 times A, and you can rewrite it as q2 times q1 times a, and what do you have? We have an integer times a. That completes the proof. Remember, if you start with two different characters, q1 and q2, you can't get it wrong here. Just one more time, and then the rest is homework problem for you. How about the next one? D divides A. How can you rewrite D divides A? A is some integer k times D. And then D divides B. So that means B is some integer k times D. And then, all okay? Anything wrong? Yeah, I hope everybody found out. Same k. No, that's a red flag. Each time you use an existential quantifier, you have to bring in something different. This k and that k do not have to be the same. So k1 for this, and k2 for that, and A is k1 times B, that corresponds to this blue, and B is k2 times D, corresponds to this green. Now, does D divide A plus B? Well, let's work out. A plus B is, let's see, A is k1D, and then B is k2D, and you can manipulate like this, k1 plus k2, and is that an integer here? Yes, that's an integer. You see this A is k1D, as I just highlighted. Let's put some space in between. And this B is k2D. So I can factor D out. I have coefficient k1 plus k2, which is an integer, because integer plus integer is also integer. So that completes the proof. And of course, you can do things like those here for all these. And as you get down, further down, things are gonna get maybe a little bit harder, but they're all within your reach. All these are homework problems for you. Remember, whenever you use the divisibility, you have an existential quantifier. So each time you use that, you have to change a character. Q1, Q2, K1, K2, or some other character, whatever. Remember those, and you'll be able to do all those. And as for the result, what can you do? You have to remember all those. Okay, so much for 1.1 and 1.2. I don't think we'll have enough time to start 1.3 now, so let's do that in the next video. And still different video will be needed for 1.4. Maybe multiple videos in 1.4 because this is a big deal. Stay tuned. See you soon.